Okay guys, so we have kind of two things that we're trying to tidy up this week really left with trig triangles. The first exercise you've got left in the textbook is to do with when we sometimes use sine rule and cosine rule with a little bit of Sohcahtoa. Now don't panic about that because I know some of you don't like Sohcahtoa. We can actually use sine rule anyway instead of Sohcahtoa, so it might just be that we have to use a rule twice. Okay, so we're going to do just a couple of examples from that. That should let you try that textbook exercise. And then the final little bit that we want to look at is how you know which rule to use, okay, when you're faced with one of these triangle questions. Because so far, the way that we've been doing it, we've done a week of sine rule, a week of cosine rule, so you've not had to think about it when it's which one's which. We also need to do a wee bit of work on bearings. I know from the work I've seen so far, some of you have actually done some of the bearings questions, even though I said not to worry about them, which is great. We will look at it for a couple of lessons after we've done this next week, and then we'll be able to move on to the next bit of trig. Okay, I'll probably do two videos because I think going over these first two is going to take long enough, and then it kind of works with you can watch two videos, try an exercise, and then watch the other video and try the other exercise. So these are all past paper questions that I'm going to do with you today, okay? It's probably the best way, and if you finish everything from the textbook and you feel like you need some more practice, let me know, because there are a few good kind of past paper worksheets out there that I can send you. But basically, the way that you're going to identify one of these questions where I'm saying to you, you might need to use sine rule and cosine rule, or you might need to use sine rule and Sohcahtoa, or whatever, is it'll always be a question that's worth 5 marks. So that's your first clue, okay? Sine rule, cosine rule questions, we've not spoken about that hugely, but they're usually worth 3 marks, occasionally maybe 4 if it's quite a problem solving one, okay? But as soon as you see a 5 marker, you're more than likely going to have to do a couple of different processes here, okay? So let's have a look at this. Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent the positions of Katie, Mona and the balloon respectively. Now, you'll see in these questions, it'll talk about the angle of elevation or the angle of depression. It just means either the angle looking up, okay, so that's angle of elevation, okay, and then angle of depression would obviously go the other way, and we'll see that in a wee minute, okay. So the angle of the elevation of the balloon from Katie is 52 degrees, so we've got that angle in there, and Mona is 34 degrees. Katie and Mona are 350 metres apart on the level ground. Calculate the height of the hot air balloon above the ground. So, what we want is that height there in a nice straight line. Now, the problem we've got is this is not an isosceles triangle. Because if it was, you could just cut this 350 along the bottom here in half, and you could do Sohcahtoa, okay? But we can't, because we don't know whether or not that distance between here and here is it half of it, is it a quarter of it, is it a fifth of it, we just don't know. So in order to be able to work out that h, you first of all need to decide, do you want to pick the left hand side of the diagram or the right hand side of the diagram. Now, to be honest with you guys, it's not going to make a huge difference, okay, so up to you. I'm going to do it one way. If you do it the other way, you'll get the same answer, maybe a slight rounding error. Okay, and you can even go away and try that if you want. I'm going to pick the left-hand side of the diagram. So I'm going to pick this. Oh dear, this is where we discover that I can't draw on this. I'm going to pick this triangle here. Okay, so H, K, B. This angle in here is 52 degrees. Okay, and in order to be able to work out the height, we're going to need either this length here from K to B, or we're going to need this length here from K to where that height drops down. Let's call that point N, okay? Now, that blue bit that I've highlighted, K to N, we've already talked about the fact that we don't really know what that distance is, okay? Because we don't know whether or not, as we said, that's a fifth or a quarter or whatever of the whole distance. So it would make sense if we could work out that distance KB, okay, so let's call that X, because then we'd be able to use that right angle triangle and use either Sohcahtoa or Sine Rule, okay, and we wouldn't need to know that side because we would have a side and we would have an angle, and we can always work out the other side then. Okay, so what we're going to need to do though, in order to be able to do that, we need to get this distance here, this KB. But that's okay, we can get that because if we draw that full triangle, and KB is what we want to work out. Now we know that that's little m in our picture, okay? And we know little b, okay? And we know this angle's 52, and we know this angle's 34, okay? And then 52 add 34. 52 add 34 is 86, so if we take that away from 180, we know this one is 94, okay? So we can use Sine Rule, because we have M is what we're trying to get, and we know angle M, and we know 350, and we've just worked out angle B. Okay, so we're going to have M over sine M equals B over sine B. So M is what we're trying to work out, sine M is sine 34, and that's equal to B, which is 350, over sine B, which is sine 94. So M is going to be 350 times sine 34 over sine 94, and with a little bit of typing in on the calculator, just give me 2 seconds guys, divided by sine 94, we get 196.19. Okay, so we don't want to round it too much, so it's 196.1954 and so on. Let's go for 196.2. Okay, and that's in meters. So now I can go back to that right angle triangle that I was working with up here and say, right, well, we now know that this is 196.2. How is that going to help me get the height? Now, just for a bit of space, guys, I'm going to draw it again. Okay, so we're down here. We've got 196.2. We've got H is what we're trying to work out. We've got 52 degrees, and this angle here, remember, is 90. So you can again use Sine Rule. Okay, you've got that angle on that side, that angle on that side. So if you prefer using Sine Rule, go off and do Sine Rule again. That's absolutely fine. I am just going to show you it with Sohcahtoa, because I know some of you have got a thing about Sohcahtoa. So here's a wee opportunity to revise it. This is your opposite side, opposite the angle. This is your hypotenuse, the one opposite the right angle. And this is your adjacent. So we write down Sohcahtoa. We know the hypotenuse, and we're trying to work out the opposite. The one with 2 ticks is sine. It's sine of the angle, which is 52 degrees, equals the opposite, which is little h, confusingly here, over the hypotenuse, which is 196.2. So that little h is going to be 196.2 times sine 52. And we do that, and we get, helps if we put in the sine, we get 154.6. Okay, so the height of the hot air balloon above the ground is 154.6 metres. So basically, guys, in terms of the marks, you get 3 marks for your kind of Sine Rule part here, and then you get 2 marks for this kind of final part, whether you use Sine Rule again or Sohcahtoa. Now, there's quite a lot going on there. You might want to kind of stop that, rewind it and watch it again. You might want to try the question yourself and then check with my answer. Okay, I'm going to do one more example, and then, as I said, I think, yep, because this is already 10 minutes long, I'll stop the video and I'll do another video for the other question. Okay? So, this is a similar question. Again, look here, you can see the 5 marks. There's your clue that we're going to have to do a kind of double process. This is one from a credit paper a few years ago, and here's where we're talking about the angle of depression. Okay, so it's looking down from a cliff top to 2 yachts. Okay, we've been asked to calculate the distance of the, not the distance, the height, sorry, of the cliff. Okay, so we have 2 triangles. We have this kind of slanted triangle here, I guess you would call it. Oh, sorry guys. Okay, and then we have the right angle triangle that gives us the height of the cliff. Okay, so height of the cliff is there, and we know that this length here is 89. Okay, or instead of that little triangle, that kind of PCF one, okay, and then this is PYC, some of you might actually see that big right angle triangle. Okay, and you could work with that as well. So we've got 2 options to get the height. We can either work with this big one that I've just highlighted in blue, or we can work with the little one, the PCF one. It's not going to make a difference. Okay, again, I'm just going to do the question one way. I'm going to use the PCF. Okay, but you could use the PYF one, and that would just be slightly different. Okay, so I'm going to get rid of that blue just so we don't get confused. Now, what we need to realise, guys, is we've got not very much information here. What we've got is we've got that this little angle in here is 27 degrees, okay? And then that therefore means that this angle here, from here to here, okay, must be 90 minus 27, which must be 63 degrees. So if we were using the big right angle triangle, okay, we would use that is 63 degrees. Now, we're also told that from here to here is 52 degrees. Okay, so that helps us work out 2 things. The first thing that helps us work out is the size of just this little sliver of an angle. So that pink bit there is going to be 52 take away 27. Okay, which is 25 degrees. So that means that angle in there of this triangle, okay, is 25 degrees. Okay, it also tells us that if that little pink bit's 25 degrees, and we know that from here to here is 63 degrees, then what's left, the 63 minus the 25, which is 38, is that angle in there. So there's quite a lot of angle work going on here to begin with. Okay, now from there, that's still not enough information. We've got this angle, which is going to help. We're trying to work out the height, but we need another length. Okay, so the other length that we could get would either be C to F or P to C. Now, I've got an angle and I've got a side, so I'm going to tell you that we really want this P to C here. So we're going to call that X on both triangles. In order to get that, I need to get this angle. So how am I going to do that? Now, just to make life a wee bit clearer, guys, I'm going to clean this diagram up again. How do I get the size of this angle here? Now, we need to think back to alternate angles, Z-shaped angles from first year. This angle here is the same as that angle there, that 27, okay? So this angle down here is 27 degrees. So now I can use sine rule, okay, to get that length PC, and then I can use that to get the height of the cliff. So these are complicated questions, guys, I know that, okay, but let's see how we get on. So I'm trying to get X, which in this case is little y, okay, And I know little p, okay, so I've got y over sine y, or if you prefer, let's change all the letters, so we've got a, b's and c's. Okay, so we'll make that a, which makes that little a. We'll make this b, which makes that little b, and then that's c as usual. Sorry guys, this is jumping about a little bit for some reason. Okay, so we have a, which is what we're trying to work out, x, over sine a equals b over sine b. Okay, a is x, sine a is sine 27, b is 89, and sine b is sine 25. Okay, so x will be 89 times sine 27 over sine 25. Okay. And when we calculate that, we get 95.6. Okay. Now that, of course, guys, is not us finished, but that's us got 3 marks. Okay. There's quite a lot to get there because we've had to do some weird angle stuff and everything, but we've now got that distance there is 95.6. So that's going to help us, because remember what that's telling us is that's telling us that this distance here is 95.6. We'd already worked out that this angle here is 38 degrees. So now, with that information, 38 degrees, 95.6 metres, I can work out the height of the cliff, either using Sine Rule again or using Sohcahtoa, because there's my right angle, this is the opposite, this is the hypotenuse, this is the adjacent this time. So if we've got the adjacent, we're using cos. Cos of the angle, which was 38, is A, which is h over x, over h, sorry, which is 95.6. So h is going to be 95.6 times cos 38, which is 75.3. So the height of the cliff is 75.3 metres. Just double check, did they want us to round it to anything specifically? No, they didn't. It just says calculate the height h metres of the cliff. Okay, these are complicated questions, guys. You may need to come back to me and ask me to go over certain questions again. It is not a problem. Okay, please take your time with this. It's one of the reasons I'm not setting you as much work this week. Okay, because you need to really concentrate on this.